Dear students, welcome to online class, and today we are going to have a lecture on relations and functions, and this is lecture 4. I am Sudipayan Bhattacharyya. I am with you, and previously I have given 3 lectures on relations and functions. I hope you have already attended these online classes. If not, then please attend those classes and then come to this class. In this class we will be talking about inverse functions, various type of functions, composite functions, piecewise defined functions, and absolute value function. So inverse function. If f of x is a function, then the inverse function of f of x is denoted by f inverse of x, where f inverse of x is such a function that it brings each of the outputs of f of x back to their associated inputs. What does it mean? For instance, look, here a function is defined such that 1 turns into a and 2 turns into b. And if we denote this function as f, then this function b to a, where a turns into 1 and b turns into 2, will be called f inverse. That is, inverse function brings each of the outputs back to their inputs. Let's take another example. Let f of x equal to 3x plus 1. Then what does this function say? This function changes the input by multiplying 3 and then adding 1. Like if you use 5 as input, then this function will multiply 5 by 3, then add 1, which means 15 plus 1, that is 16. And look, if you use minus 2 as input, minus 2 will be multiplied by 3, that is minus 2 into minus 3, minus 6. Then it will be added 1, that is minus 6 plus 1, that is minus 5. Now, if we want to get back the input from the output, say you are given 16, you want this 5 back. What you have to do? You have to subtract this 1 first, then divide the result by this 3. So to get back the inputs from the outputs of f of x, we have to subtract the added 1 first, then divide the result by 3. What does it mean? If we want to get the input back, then we will use this function x, any number, subtracted 1, then divided by 3. This function is going exactly opposite to this function. This is why this function is called inverse function. For example, if you use 16 in this function, then you will go back to 5. If you put 16 in this function, you will go back to 5. F inverse 16 equal to 16 minus 1 by 3, that is 15 by 3, that is 5. Again, if you use minus 5 as the input in inverse function, you will get minus 2 back. This minus 2 back. How? Minus 5 minus 1 minus 6 divided by 3, that is minus 2. So, if a function is given 3x plus 1, then inverse function is x minus 1 by 3. Remember that an inverse function of a function, say f of x, is the inverse rule of for f inverse x. We get the domain of f of x as range. For f inverse x, we get the range of f of x as domain. That is, domain and range interchanges when we invert a function. Inverse function of a function is possible only when the function is bijective. What is bijective? Bijective is 1, 1 and onto. The function must have to be 1, 1 and onto to be invertible. Now I have some work for you to be done. Please write down these questions in your copy pausing the video and try to solve them, then go to the next topic. Now we are going to learn about various types of mathematical functions. We have learned about one-one function, on-to function, bijective function. Also we have learned about identity function and also constant functions. We are going to categorize the functions from other point of view. Some functions are called algebraic function, such as 2 minus x divided by 3x minus 2. This function is algebraic. Why? If any algebraic expression is used as a function, then this function is called algebraic function. Like polynomials or algebraic fractions or algebraic expressions, binomials, they are algebraic functions. Trigonometric function. The trigonometric terms or operators make some change to the variables. Therefore, these are called trigonometric functions like sin x. You can use also cos x, tan x. They are trigonometric functions. Then exponential function. Exponential functions are functions of exponents. If you see any variable or function containing variable appearing in power or appearing in exponent of a function, then this function is called exponential function. Here you can see that f of x is equal to 3 to the power 2x plus 1. Here x appears as power of a constant 3. Therefore, this function is called exponential function. Logarithmic function. Log is the inverse function of exponential function. Whenever you see this term log or ln or ln in a function, this function is called logarithmic function. We will learn about logarithmic functions later in detail. Inverse trigonometric function. Inverse trigonometric function is a kind of function which acts inverse of trigonometric function. Like if I ask you what is the value of sine 30 degree, you will reply that sine 30 degree is equal to half or 0.5. And if you ask what is sine inverse 30 degree, I will say sine inverse 30 degree is nothing, but sine inverse half equal to 30 degree. That means sin x gives us a number when we input an angle, and sin inverse x gives us an angle when we input a number, like sin inverse root 3 by 2 equal to 60 degree, or sin inverse 1 by root 2 is equal to 45 degree. This is how inverse trigonometric functions takes numbers as input and gives angles as output. We will learn about inverse trigonometric functions in detail in our intermediate class. Composite functions. What is composite functions? Like suppose you were given two functions f of x and g of x. Now here input is x, but if you use g of x instead of x as an input of function of x, then it is a composite function. It is composite function of f and g, and this function is shortly written as f o g x, that is function of function, which is composite function. And another composite function may be written as g of fx. Here we used f of x as the input of g of x. This is the function g and this is function f. If we input f as input of g, then we will get a new function which will be written as g of x. Now we are going to see an example to be clear. Suppose f of x is given like this. F of x is given x square minus x, and g of x is given like this, sin x. Now f of gx, which means in function f we will input g. So in function f we input g of x. What is the g of x? g of x is actually nothing but sin x. Therefore, we have written sin x instead of g of x. And what is the duty of f? The duty of f is actually squaring the input, then subtracting it from the square. So here input is sine, we will square the sine and subtract sine, that is sine square x minus sine x. So the composite function f of gx is a new function which is composed by x square minus x and sin x. Now we take g of f. What to do with g of f? G of f is a function where fx will be acting like an input. Here we have put f of x in g, and what is the value of f of x? X square minus x. Now x square minus x is the input of g. G is nothing but sin x, therefore g will convert into sine and the input will be x square minus x. Therefore g of f of x is equal to sine x square minus x. This is a composite function brought out by f of x and g of x, where f of x is the input. So this is all about composite functions. Now you have work to do, actually two works to do. I have given you two functions in each of the activities and you have to find out the composite functions. Please write down these problems in your copy and try it yourself, then go to the next topic. Our new topic is piecewise defined function. What is piecewise defined function? Look at the functions below. F of x equal to x square semicolon x greater than 1, 2x minus 1 semicolon x is less than equal to 1, and h of x. What is h of x? X semicolon x less than minus 1, 2x semicolon minus 1 less than x less than 1, x square semicolon x greater than 1. These type of functions are called piecewise defined function. Look at these functions. Here you have some condition x greater than 1, and here is the rule x square. Here is a condition x less than 1, then here is the rule. This function means whenever you have an input which is greater than 1, you have to square it, and if the input is less than or equal to 1, then you have to multiply this input by 2, then subtract 1. For this function h of x, if you have an input less than minus 1, then don't change it. If the input is in between minus 1 and 1, then multiply this input by 2. If the input is greater than 1, then square it. One function but three rules for three different conditions. Both of the functions have different rule for different cases. This kind of functions are called piecewise defined functions, or you may call it piecewise function. Let's see an example. Let's take a function like this. The first one, f of x. F of x equal to x square semicolon x greater than 1, 2x minus 1 semicolon x is less than 1. Now you are supposed to find out the value of f of minus 2, f of 2 and f of 1. The solution is, as minus 2 is less than 1, minus 2 is less than 1, that means it is in second condition. Therefore it is satisfying the second condition. Then by second condition we have to multiply minus 2 by 2 and minus 1. 2 into minus 2 minus 4, and then minus 1 minus 5. As 2 is greater than 1, this 2 is greater than 1, then 2 is satisfying the first condition. Therefore f of 2 will be 2 square, and then f of 1, what is f of 1? Look at the conditions. 1 satisfies the second condition, that is 1 is equal to 1, that is 2 into 1 minus 1. Therefore f of 1 equal to 2 into 1 minus 1 equal to 1. You are given a piecewise defined function and you have to find out h of 1, h of 2, h of minus 1, h of minus 2, h of 3, h of 0 and h of 5. I think to solve this question you need at most 3 minutes. Then go to the next topic. In this section we will learn about absolute value function. Absolute value function of any number x is the amount of distance of x from 0 along the number line, and absolute value is expressed by bar x bar, that is modulus of x. Sometimes absolute value is called modulus. So this sign is called modulus x or mod x. For example, absolute value of -3 equal to modulus of 3 equal to 3. Because look at the number line, from 0 to 3 you will get 3 units. Therefore, absolute value of -3 is equal to 3. Similarly, absolute value of 5, then modulus of 5, it will be 5, because from 0 to 5 you can see 5 units. The distance is 5 units. Therefore, modulus of 5 equal to 5. Distances can never be negative. Therefore, it's clear that absolute value is always non-negative. It's not positive, it's non-negative, because absolute value can be 0 but it will not be negative. Therefore, absolute value is always non-negative. If you get a negative number, you have to multiply -1 with this number to make it positive. Like modulus of -3 equal to minus of -3 equal to 3. If you get a non-negative number, then you have to keep it unchanged. Using these conditions in a function, we can define an absolute value function in this way. Modulus of x equal to minus x whenever x is less than 0 and x whenever x is greater than or equal to 0. Now you are given that f of x is equal to modulus of 2x minus 1. Then determine these values, f of minus 1, f of minus 2, f of 0, f of 1, f of 2. I think this is enough for today. Special thanks to you for your active participation, and don't forget to subscribe and active notification using the bell icon. Bye.